we're at that moment right now where there's the potential technologically, economically, socially to make these possibilities of urban transformation be real. They've been dreamed about for a long time. Now technology companies have decided to get religion about smart cities and about bringing technology to economic and social and political change. And you get to decide after I've spoken for 15 minutes whether or not we're up to the task or not. We're at that inflection point where we think there is a sufficient market demand to justify putting the research dollars behind an effort to build the products and services that will make this happen. We call this the Internet of Everything because when you're trying to remake the city, it's not just the things, the Internet of Things, that's going to be important because things are critical, but they're not for everybody the most critical factor. Our people connections tend to be the most critical factor in our lives. But the process by which we do stuff and the data that sits behind those processes is as important as the thing. The illustration perhaps to make here is coming from Chicago a few days ago, we deployed a smart parking system that enabled the parking meter to get lit up. So it wasn't just the lit meter that became an internet-enabled, internet-connected, intelligent device, scattered, I think, 400,000 of them in the city, but the possibility of that process of paying for that parking space or finding that parking space being transformed because the data that's streaming off of that parking meter or the wireless device in the parking space suddenly changed my whole process of finding the parking space or interacting with the parking meter and paying for it, and maybe avoiding getting a ticket in the process when I go over my allotted time. What we're trying to do at Cisco is capture the wave. We've been pretty good at this for 30 years now. We haven't had an unprofitable year, and we're trying, amidst a lot of disruption around us, to continue for the next 30 years to do that. We like to say that we stay ahead of the market transitions. The big market transition right now is that all the stuff in the world is waking up, becoming intelligent, and transmitting data. And the question is, can we capture the value that's coming off of all that smart stuff, not just the supercomputer in your pocket, but everything else around us, the lights, the doors, the HVAC systems, all the rest of it getting awakened? Can we take advantage faster than perhaps the adoption and advantages gained from electrification or from telephony? And we think, based on the research, our research, that we're actually about 5 times faster in the adoption of these innovations compared to electrification and telephony. So what will it take? We think it's pretty obvious, at least to us, having been through the process of building the internet and having 80% of our internet transactions flowing through our equipment around the world, we get to see inside the whole process of the last 30 years of building the internet. Now, this next innovation, we have an opportunity to take some of the lessons learned, not to apply all of them because some of those lessons are going to be irrelevant for the transformation about to take place. But we think the last 30 years of building the internet is a pretty good guide for how things might evolve for this next iteration, this next evolution. We think it's these things that you see at the bottom. The fundamental infrastructure, getting that right, the open global standards, getting that right, and the focus on the operation. Not the IT, but the OT, the operational technology, the stuff that actually makes a building like this work, as opposed to the IT department, which has its closet where boxes with blinky lights are transmitting their data. It's the operational technology where the action is going to be. So we have a lot of these choices that we think cities are going to grapple with, and we're seeing this already in about 100 cities where we're doing projects. And they're embracing the innovations. They're generally not building themselves the innovations. Big, rich cities like London and Singapore and New York will build some of their own innovations. But more likely it's going to be companies like yours and universities like yours and NGOs like yours who are going to be providing this, and that will be scaled and replicated and transferred to cities around the world. And these are some of the opportunities that we think the cities are going to embrace. But it will require some big steps that I've outlined here. And at the bottom of that, of course, is the big one, the privacy, the security of the data as it's being transported, but also where it may reside. At the edge of the network, in the parking meter, in my home, in the grid, or in the data center. So we're now really trying to get to, the fundamental ingredients that we think are going to be characteristic of the smart city. We don't see a lot of smart cities yet, but we see a lot of smart initiatives that are building toward the smart city. We think the networks and the systems that cities adopt are going to have to be these four things. We talked about intelligent. They have to be observable. They have to be visible, making the invisible visible, critical to every city's success. Automated. This is not going to be run by men in white lab coats, which I dare say is sort of the IBM model for doing this, which is why they want all the data transported to the data center. We're interested in keeping the data where it is, at the edge of the network, in a building like this, before it ever needs to go to a data center somewhere where the energy consumption is off the charts and where the security is vulnerable. But we want this to be transactive. We want things to happen because it's not a one-way from the parking meter to the data center. It's not one way from the parking meter to the driver looking for a parking space. There's all sorts of transactions taking place dynamically, and some systems like SF Park have decided to do dynamic pricing based on that dynamic flow of data. So we think that every city that adopts a smart city strategy that's worth its salt is going to have to really think about the components of that network. Has to be focused on the solution. Nobody really cares about the systems behind. It wants to know what's you as a citizen or you as an enterprise in the city want to know what's the solution that you're delivering to me to solve my problem, which is a combination of products and services and software. What's the architecture? Is it open? Is it extensible? Is it adaptive? A lot of systems are really not, and we want architectures that really can survive the test of time. We know what those are, which is why the internet works today, by the way. But it also has to be driven around services. We actually have to deliver a valuable service to the end user, which means we build an ecosystem of partners. And I'll get back to that toward the end of this presentation. So the trend lines are very favorable for what we want. All the costs are declining. Not great for Cisco, by the way, that everything is costing less, but we're adapting. So now, of course, as that cost drops and it becomes easier for enterprises to grow and develop innovations, cities to adopt those innovations, citizens to benefit from those innovations, enterprises to grow on top of those innovations, it benefits everybody, it lifts all boats. But it's all speeding up. So let's rethink Maslow's hierarchy here. We think it starts, with the fundamental layer, the connectivity. If you're not connected, it's not real. My boss likes to say he's got two teenagers and they have two states in life. They're either asleep or they're connected. And there's nothing else. You know if they're asleep because they're not connected. But the analytics that we've heard about today, vital, because if you're connected and you're streaming data, wonderful. It helps to see the video clip somebody sent you of the cute cat. But it doesn't necessarily help you make a decision. Watching cute kitty videos is interesting, but it's not a decisive point in your day to make a choice about whether to park here or there, whether to drive or not to drive, whether to ride share or not to ride share, whether to even commute or not commute. All of those choices can be facilitated, enabled, and made more sustainable, we think. And you go up the chain until you get to the point where the benefit is universal. And that means, by the way, as you see there, what we think is a new business model, which means that the user gets valued for their data. Right now, Facebook builds a multi-billion-dollar business taking advantage of your free data, which doesn't have to be free. And lots of new business models will emerge that value you as the data provider. So we talk about this amazing shift that's taking place, where the convergence of Moore's law, of Metcalfe's law, and of the possibility of big data analytics. And we can talk about this more during the question and answer period because I know I'm going fast. But Our fundamental story is every company, every city, every government agency, every national government agency is going to be a digital company, a digital enterprise, because everything is migrating to its fundamental unit of measure and value, which is what's the information you're providing to me that solves my problem. And deliver it to me as a service, thank you, preferably free, since we've been educated so well by Google, and make it all scalable. And if I decide I want to make a real-time decision, give me the value that's going to give me the real-time decision, preferably by one press of the button. I don't like my decisions too complicated, thank you. So we think that to build the solutions that can make that possible, we have to have the vertical solutions, smart parking, smart lighting, smart energy, smart houses, but also the horizontal platform on which that's possible. So let me just talk a little bit about vertical, and then at the end I'll talk a little bit about horizontal, because you can't have one without the other. Our approach around the Internet of Everything, which we've written a lot about, and you can search for all sorts of studies that we've done about different sectors of different markets, and the broad opportunity, which is $19 trillion, we think, of trapped value in the economy that can be released either by cost savings or by new revenue. So we've built a group of innovation centers, we've put some funds together, and we're building the applications with a developer network. And let me talk about those. So we have in the world now just a few of these initial innovation centers. This is the result of about a year's worth of our work. And they're in cities that we think have the promise and the potential to really be transformational for the whole world and not just valuable to that particular city. And in those cities, we're not just applying new solutions with our partners from IBM to General Electric to Schneider to Siemens, Johnson Controls, lots of others that you know and many names that you don't know, but we're trying to do it differently in each place with a different combination of actors and a different focus. And so you have a lot of different companies that have become partners, some of which we invest actively in, some of which we partner and go to market with together, some of which we integrate our technology and their technology. So when you buy Johnson Controls, you're often buying the capacity for a Cisco-powered network or a similar IP-based network to talk to that Johnson Control system. But really the power, we think, is dispersed in the developers. The Lone Ranger who's sitting in front of a screen and building amazing solutions. Java has, I think, 6 to 9 million developers, depending on how you count it. That's a powerful resource that Java can apply in its bid to do what Larry Ellison wants, which is take over the world. So we do the discover process with our partners. We build the APIs and the software developer kits we provide and the reference materials. We provide lots of tools to build, and then we provide labs and other resources to help those developers test. But we have to innovate with local talent, and this is a picture of what we're doing in Chicago with 2 centers, 2 accelerators, 2 incubators that we've helped to fund and organize, one at University of Chicago and one that's freestanding. 1871 was the year of the fire in Chicago, so that's the metaphor. And our goal is in each city to really build an ecosystem. But we have another approach, which is to build a global ecosystem, and not just around products and services and solutions and stuff you can sell, but the underlying knowledge. And that's where Meeting of the Minds comes in. You may have met the 2 people here, Jesse and Dave from the Meeting of the Minds Secretariat. I'm on the board. We've had numerous of you participating in the program over the years. It's coming to Richmond next year. And during the course of a 12-month cycle, we go through a whole process of identifying key issues, spotlighting key innovators, testing, not us, but the various parties in the network, testing those innovations to see how real they are, sharing that through the blogs and the tweets and the monthly webinars. This month's webinar, I think it was yesterday, was all about how we measure apples to apples. Because if you can't do the measuring, then you can't manage it, you can't improve it, it's not real. So we try to use this knowledge exchange network, Meeting of the Minds providing the platform for that. We try to use that network to uncover the big challenges that company like us or the other sponsors like Ernst & Young or IBM or Ford Foundation or Barr Foundation, or in the case of this year's program, Detroit Future City, since it was convened in Detroit. And that year-round program allows us all sorts of access to insights that we couldn't get for ourselves. So that's why it's an open knowledge exchange network, and we depend on that at Cisco. All the other sponsors do as well, because we want to have an impact on not only our own understanding, but the way that a city like San Leandro might decide it wants to adopt this rather than that as an approach to encouraging what we're talking about today, which is building the innovation economy, building the innovation ecosystem, and having this transformation take place from the bottom up. Because the big gorilla like Cisco, with 85,000 employees and almost $50 billion in annual sales, it's hard for us, a muscle-bound giant, to really be adaptive and flexible. It's easier for young upstart companies to disrupt the field, and that's why you saw that we're investing in those types of companies as often as we can. So the annual meeting will take place here in October in the East Bay in Richmond at the Craneway Pavilion. It'll be an opportunity for a lot of knowledge exchange among 400 selected leaders. Cisco and all the other sponsors, for-profit and nonprofit, use it as a place to really see what are the emerging opportunities. And we think that, you know, the innovation ecosystem in the East Bay is very rich, which is why we were encouraged when the Meeting of the Minds staff said, let's bring it from Detroit, where it was this year and the previous year in Toronto and the previous year, let's bring it to the East Bay. These are some of the themes. Some of them are very familiar to you, some of them maybe not so. We've talked a lot about open data and big data, the power of that type of data to transform old, stodgy institutions like utilities, who don't move very fast very often. The annual meeting format is designed to be very open-ended and to allow for a lot of those young green shoot innovations to be in the spotlight. We use telepresence to enable a global event to connect the dots. We do, you know, normal conference things like this, but not so normal, like bringing it out to the neighborhoods, not just Richmond, not just Oakland, but there'll probably be other places where we bring clean and green bus loads of participants. If you have suggestions here in the East Bay of what they should see, let us know, because they'll come from 15 to 20 countries. So the delegates we just had in Detroit for a few days, you can see here it's a nice mixture with scholarship participants, scholarship recipients, young and old, public sector and private sector. Lots of media, lots of geographic representation, which was quite nice. Lots of different types of delegates, and lots of cool sponsors. So let me say this about our approach at Cisco and what we would like to do, not just with the city of San Leandro, and Deb and I are talking about that and bringing in a company or two that are in our partner network, particularly around the wireless networks, talking to the wired networks, so that a building like this has a more powerful wireless opportunity to connect to the broadband fiber network. What we want to do is really use multiple channels, our investment capital, our existing engineering talent, 28,000 engineers scattered around the world, mostly here in the Bay Area and in North Carolina, but lots of other resources that our company can provide and our partners can provide. We think that, you know, there's just a huge demand, pent-up demand, for things that are very practical, very specific, but also some things that are abstract, like new governance. Because if we don't figure out how to make these decisions and engage citizens, you know, we're just talking and creating hot air. So that's the conclusion of my own attempt to try to respond to the organizers' mandate to get a few words here about what we're doing that we think can be valuable to this discussion about building an ecosystem. And I've got, you know, 53 seconds, so let's go for some questions before I turn it over to you.
We'll go ahead and do maybe one question now, and then we'll have time for the panel as well.
All right, one pressing, burning question, and then later. Oh, yeah.
Thank you. Gordon, you had a line in your presentation that talked about the growth of sensors exceeding the growth of bandwidth. Can you talk a little bit more about what you envision in terms of that growth and what kinds of sensors being used for what kinds of applications?
Yeah, the world of sensors is a pretty amazing place, and it's as varied and diverse as any other that you might expect in the realm of technology. So a lot of sensors are, let's call them burst transmitters. Yeah, every 3 hours, something will transmit information to somewhere that says, here's my condition. Take a temperature reading. And I need to know that because this helps me determine, is that garbage pail filling up because it's every 3 days? Or is that pump working well every 30 minutes during a storm, or every 3 minutes during a storm? I want to know the pump is working, especially because there could be a brownout or a blackout, which will make that pump vulnerable. So every sensor is essentially performing a different task. The challenge is that most of our networks are not geared for that kind of data because, frankly, the AT&Ts of the world don't think it's a great business. Machine to machine is more of the communication in the world is now between machines than between people and people or between people and machines. So we have to, that's why we talk about architecture. We have to architect the network to be able to accommodate all the different kinds of requirements. When William was up, we talked about high-speed video for health and education. We have to configure the network to accommodate that as we do the sensors, as we do the text and the audio and the video, which, by the way, we've done a pretty good job getting the networks ready for that. So this is the kind of world we're facing. Very complex. Everywhere is going to be a little different. This building will be different than the building across the way, which makes it hard because we want to universalize everything. The TCP/IP revolution was basically everything was the same. All data was the same. You can't really do that when you're dealing much with the physical world, which is why we've only connected about 1% of the whole physical world. We've connected 75% of humanity, but we've only connected 1% of the physical world because it's actually hard to do. On that theme, I'll sit down.
Thank you very, very much, Gordon.